My name is Vernanda Anugerah Putra. My metric number is 185110, and today I am going to explain how to evaluate this equation using the Riemann sum theorem. So now, as we know, that the first thing that we need to do is to find our delta x. Our delta x can be gained from b minus a divided by n. Now we know that our b is 4 and our a, which is the bottom one, is a 1. This n will still stay as n until the end of the equation, so we're not going to worry about n. So 4, I'm going to plug in 4b, I'm going to plug in a, which is 1 per n. So we have our delta x as 3 per n. So now the next thing that we're going to do is to find our xi. This is going to result in our fxi, where we put our xi into the original equation. So we're going to find our xi by taking a, which is 1, and then plus I, which is a variable that we're going to replace later with the sum law, and then we're gonna times it by delta x. So now we're going to plug in all these variables. A is 1, delta x is 3 per n, so I equals 3 per n. So we can't simplify this further, so our xi is I 1 plus I times 3 per n. Or we could actually write this as 1 per 3 per ni. So now what we're going to do is to plug in this xi into the original equation to get our f of xi. So now, as we know, that is x squared minus 4x plus 2, so we're just going to straight up plug in our xi into this equation right here. So we have 1 plus 3 per n I quadrant minus 4 times 1 plus 3 per n I plus 2. So now we have this. We are going to basically elaborate this further. So we are going to open this up. So we're going to get 1 plus 6 per ni, because this is going to result in 2 per ni. And then this is going to be to the power of 2, so we have 9 per n quadrant I quadrant. So now we're going to times minus 4 to minus 2, 1, which is minus 4. And then minus 4 times 3 per ni, which is minus 12 per n I plus 2. So now we're going to simplify this further by basically simplifying it. So we have our 9 per n quadrant, so we're just going to put that at the front. N quadrant I to the power of 2. Then 6 per ni minus 12 per ni, it's going to result in minus 6 per ni. No, sorry, that's not right. Sorry. 6 per ni. This is going to be here, and then minus 4 plus 2 plus 1, so it's going to be minus 1. So this is our f of xi, which we will use in the Riemann sum theorem later. So now, in order to get our Riemann sum, we are going to use our f of xi and our del. We're going to use f of xi, this, and we're going to use delta x right here. So we're going to use these two equations to find the result of the Riemann sum theorem. So the Riemann sum theorem goes like this: limit n goes to infinity sigma n I equals to 1, and then f of xi times delta x. So now we're going to plug in these two equations. Now that our f of xi is this equation right here, and we have our delta x is 3 per n. So we're going to plug in all of these to do this kind of fast. I'm going to use the, well, we're not going to use that. Sorry. Well, we're just going to write it. So we have lower limit and infinity sigma, and oh, it's a little bit crude. I'm so sorry. So we have our f of xi. So we have 9 and to the power of 2 I times to the power of 2. Now we're going to make a bracket here, minus 6 per n times I minus 1. And we're going to time that with 3 because we know our delta x is 3 per n. So we're going to, so now we're going to times this. So, well, this is a bit crude. Oh, these are all the same, so you know what I am saying. So we have 3 times 7 per n, so we have 27 per n power of 3, because and to the power of 2 times n is n2 plus n1, so n to the power of 3 times I quadrat to the power of 2, and 3 times 6 is 18 per n to the power of 2 times I minus 1 times 3 per n. And we're not going to left this one out because this is going to be used in the sum laws. So we see that there is 2i here. We have I quadrat and I. So now the sum law dictates that I is equals to n times n plus 1 per 2. And sum law also dictates, because we have a I to the power of 2 here, that I to the power of 2 is equals to n times n plus 1 times 2n plus 1 divided by 6. Because we are going to isolate basically every equation to the left, and we are going to isolate the sigma I, so we can actually replace them with both of these equations. So we're going to replace the I quadrat with this one right here, and we're going to replace I with this one right here. So now let's write that. That is going to be pretty long. So limit n to the power of infinity. So we have, of course, our first equation right here, 27 times quadrat n to the power of 3 times which is, we know that it's this one, right? So we are going to isolate that, minus 18. Oh, sorry, this is supposed to be limit 18 times sigma I times minus 3 per n, which is of course another limit, times sigma, and we have 1 here, so we're going to plug that in, because sigma n I is 1, because sigma 1 is equals to n. I forgot to mention that, so I'm going to do that. Right, so now we have this, so now let's replace all of these sigma with these right here. So let's do that. Let's do that right here. I'm going to right. So we have 20 limit n of to the power 27 per n cube. So we have right here. So we're gonna replace sigma I quadrant with this equation right here. So it's going to be quite long in actuality. 10 plus 1 per 6. So now we're going to select these. Let's get a minus, and we have limit n to infinity 18 per n to the power of 2, and we're going to replace it with this. So let's do that. n plus 1 divided by 2. And then we have a limit of this 3 per n. That doesn't work as much as I hope. I'm going to copy that. A lot easier. Minus. Now we know that sigma 1 is equal to n, so we're going to write n. So now from here we can already know, because n goes, for when we apply the limit of n to infinity, we know that these n are not going to matter at the end, and the only thing that matters is these numbers right here: 27, 6, 2, 18, 2, and 3. So now let's simplify all of this, because this is going to be cancelled out in the end with the n to the power of 3. So we are just going to swipe this out, because this is 1. Now we have 3. Now we have 3 and 27 here. We can actually do this division right here. 9. So now we have 18 and 2. We know that this is going to cancel out in the end. So let's basically care about only about these two numbers, 2 and 18. So 2 is 1, 18 is 9. So now, of course, n divided by n is going to be 3. So now we know that we're going to apply the limit, which means all n goes to infinity, and the only numbers that are going to be left are these numbers right here: 9, 9, and 3. So let's write those down. 9, of course here, minus 9, minus 3. So 9 minus 9 minus 3, it's going to be minus 3. And this is the result of our Riemann sum theorem, which is minus 3.